Alright, this is lesson 1.12 of our Precalculus 11th class. Unit 1 is called Radicals and Rational Exponents. Lesson 12 is called Radical Equations. What we're going to learn in this lesson is how to solve radical equations, and then we're going to talk a little bit about domain restrictions on radical equations. So radical equations are equations that contain the x variable inside of a radical. So example A and C would be examples of radical equations. B would actually be a quadratic, and D would be a trig equation. Okay, so when we take a square root of something, we can only take a square root of positive numbers. So long as we're working with real numbers, we can only take square root of positive numbers. So we can take the square root of 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. But we can't square root any number less than 0 without getting imaginary numbers. And of course, imaginary numbers aren't real. So when we say domain, we're talking about what values can we put in for x. And then specifically, what values can we put in for x without getting imaginary numbers? Now that we know what imaginary numbers are, we have to put that caveat in. So we have this thing. The thing inside the radical is called the radicand. And so the domain restriction is that the radicand must be greater than or equal to 0. Now you can write that like this. If x is the radicand, x is greater than or equal to 0. Otherwise, if you want to write it more fancy, you can write full set notation. That's what this is called right here. So we're saying I call them mustache brackets, denote our set notation. We have x such that x is the element of all real numbers, where x is greater than or equal to 0. But notice this is the key piece right here that we're talking about for domain. The rest of it is just being more specific that we're talking about real numbers and x is our variable. The way I like to describe it is that the domain is who is invited to the tea party. Well, we're having a tea party for x's, and x's we're defining as only the real number x's, and then we're making a list of which one of those x's are on our tea party list. If that makes no sense, don't worry about it. Okay. So if I wanted to solve an equation, first thing we want to do is get the radical expression by itself on one side of the equal side. We have a plus 6 that we want to get rid of, so we'll get rid of that first. Once the radical is by itself, we'll square each side. So we'll square the square root, which makes the square and the square root cancel out because they're inverse operations. And then we'll square the 3, so that'll become a 9. So then we have 6x plus 57 equals 9, and we're just going to solve like a simple linear equation. We get negative 8. Now, because we have a square root, we do have to check our domain restriction. You see the radicand in this case is 6x plus 57. So 6x plus 57 must be greater than or equal to 0. Well, that's an inequality that we can solve for x, and we can do so. X must be greater than or equal to negative 9.5. So if 6x plus 57 must be greater than or equal to 0, that means the x right here has to be bigger than or equal to negative 9.5. If it's equal to negative 9.5, this will equal 0. But negative 8 is bigger than our answer, so we're good. Okay, so there's a couple things going on here. We can solve this equation the same way. The radical is by itself, square both sides. This time when we square the right, we're creating a binomial squared, so we have to FOIL that out. We get this guy right here. Because we have an x squared term, when I solve for x, we're going to set the whole thing equal to 0 and then factor. So then we will get two potential answers. 0 is equal to 0 times anything, so if I make the first binomial equal to 0, I get a solution x equals negative 4. But also 0 times anything is 0, so if the second binomial is equal to 0, we have another solution. So x could be negative 7. So now when we check our domain restrictions, two things we got to look at. On the left, we have a radical symbol. The radicand must be greater than or equal to 0. So x plus 8 must be greater than or equal to 0, which means x has to be greater than or equal to negative 8. And if we look at our potential answers, both are true. Now, the new piece for domain restriction, or really a new way to, one other thing we have to look at, is because we squared an x on the right, we potentially created another solution. So if you think about, if x is equal to negative 3, and you square both sides, you get x squared equals negative 3 squared, which would be positive 9. And this is just like a side example, it has nothing to do with example B. But the point here though is if I have x squared equals 9, x could be 3, because 3 squared is 9, but x could also be negative 3, because a negative squared is going to be positive as well. So when we squared this x plus 6, it's like squaring a negative 3. We could create an extra answer. So what we want to do is take our two answers, negative 4 and negative 7, and we're going to consider those answers in terms of x plus 6. So now if I take a square root of something, the domain restriction says it has to be greater than or equal to 0. So whatever this is equal to on the left has to be equal to a positive number. So x plus 6 has to be positive. If I plug in negative 4, I get negative 4 plus 6, that's positive 2, that's okay. That's in our domain. If I plug in negative 7, I get negative 7 plus 6. Well, negative 7 plus 6 is negative 1, and that's not positive. There's no way a square root of any real number will equal negative 1. Right? That's our imaginary number. So we omit negative 7. Negative 7 is not a real solution to this problem. It is an extraneous solution that was created when we squared the x plus 6. That's my work over here. So if I plug in negative 7 to both sides of the equation, we get this right here, and then we can simplify, and then we get what is a nonsensical solution. 1 equals negative 1. That doesn't make any sense. So if you try plugging in an extraneous solution into an equation, you're going to get a nonsensical equation like this. And that's how you know you can omit that answer from your answer. Alright, that's about as hard as it gets for this lesson. We can do another example. We have a square root equals a expression. We're going to square each side. On the left, we have a radical. So the radicand must be greater than or equal to 0. And we can solve over here in green for that domain restriction. On the right, we're squaring an x. So we have to consider that we're creating extra solutions. So when we plug these answers in, let's see here. Yeah, we're squaring this, so we do some algebra, set it equal to 0. We have a x squared, so we're going to factor this thing and get two potential solutions. Now, both solutions, let's see here. The first solution, x equals 3, that would be the same as 21 over 7, which is less than 22 over 7, so that works. But if I take the 3 and plug it into the right side, I get 3 minus 4, and that's a negative number. And so a square root can't equal a negative number, so we eliminate the 3 because of the right side of the equation. The other solution was x equals negative 2, and we eliminate that solution for the same reason. Negative 2 minus 4 is a negative number, and a square root can't be negative. So we've eliminated both solutions, so the answer for this question is that there are no solutions, or no solution, or NS. And that's totally okay. Graphically, if you wanted to graph this thing, we would get, let's see here, you could graph y equals the left side, like on Desmos. Go to Desmos, graph y equals this expression on the left, and then graph another line, y equals x minus 4, and you'll get a square root graph and a linear graph, and they will not intersect. Anyways, one other side note, when we are working with this domain restriction, we're working with an inequality. So whenever you divide or multiply by a negative number, so right here, we divided each side by -7 to solve for x. Because we divided by a negative, our inequality flips. And so if you think about that, in a more basic example, -2 is bigger than -10. Okay, -2 is bigger than -10, so the inequality is going to open towards the -2. But if I divide each side by -2, -2 divided by -2 is 1. -10 divided by -2 is 5. And so now the inequality opens towards the right, the 5, the bigger number. -2 is bigger than -10, but when I divide by -2, or 1 is less than 5. So when you divide by a negative, it flips the whole thing, so you have to flip the inequality. If that doesn't make any sense because I'm saying it verbally, ask me in class and I'll write it out for you, and that'll make more sense. All right, that's this lesson. Takeaways: we can solve radical equations. We also have to keep in mind our domain restrictions when solving radical equations, because sometimes the algebraic methods create extraneous solutions.